All right, in this video, we continue with some examples about current value under the guise of compound interest in Chapter 3. Please pause the video when I step off screen and record the notes in your notebook, and then press play again and I'll talk through it. All right, so the idea with current value is we're going to be dealing with situations in which we have cash flows, different amounts of money arriving at our account at different times. And what we'd like to know is what is the value of all of these cash flows at any particular time of my choosing? And hopefully the examples will make it a little clearer what I mean by that. Okay, so your great aunt Hildy gives you $100 right now, times 0, and promises, and she's good for it, great aunt Hildy's good for this, she promises to give you $200 in 1 year and $3,000 in 5 years. The annual effective interest rate that your account is operating under is 3% per year, okay? Compound interest, even though it didn't state it. So we would like to determine the current value of these cash flows, these payments, right now times 0, all right? So I set up a time value diagram of money. So at time 0, you get $100. At time 1, you'll get $200. And at time 5 years, you'll get $3,000. And we would like to know the values of all these piles of money if they're all dragged to time 0, okay? We call that the current value at time 0, denoted CV sub 0. Okay, and all I'm going to do is take each pile of money and drag it where I wish, and then add the results. So the $100 pile of money, it's already at time 0. I don't need to drag it anywhere. It's worth exactly $100 at time 0. The $200 pile of money, it arrived at time 1. I need to drag it back 1 year. So I'm going to take the $200 and multiply it by V to the first, because that drags us back 1 period. And I'm going to add those two piles together. Now the $3,000 pile, it arrives at time 5, and I need to drag it back 5 periods, 5 years in this case. So I'm going to take 3,000 multiplied by V to the 5th and add it to the other piles, right? So each pile has gotten dragged back to time 0. Now remember, V is the same, multiplying by V is the same as dividing by 1 plus I to move it back a period. So V is 1 over 1 plus I. Our I is 0.03. So this line, when I throw in our value of I, becomes 100 plus 200 times 1 over 1.03 plus 3,000 times 1 over 1.03 to the 5th, all right? Just replacing the V's with 1 over 1.03. That cranks out to $2,882 on the nose, okay? All right, now, same exact set of cash flows, $100 at 0, $200 at 1, $3,000 at 5. But now I'd like to know the current value at time 3 years. Okay, so I'd like to know CV sub 3. Okay, so 3 is my target, and I need to move each of these piles of money to time 3. So 100 has got to be pushed forward 3 years. The $200 has to be pushed forward 2 years, and the $3,000 has to be dragged back 2 years. Okay, so they're all sitting at the same time. All right, well, let's do that. $100 times 1 plus I cubed will push the $100 forward 3 periods. $200 times 1 plus I squared will push the $200 forward 2 years, from time 1 to time 3. And $3,000 times V squared will drag that $3,000 back 2 years, from time 5 to time 3. Again, I is 0.03, so V is 1 over 1.03, all right? So I'm going to have 100 times 1.03 cubed, 200 times 1.03 squared, and 3,000 times 1 over 1.03 squared, right? And all that cranks out to 3149.24 in my calculator. All right, last part of the example, same exact cash flow setup, the same 3 payments at the same 3 times, same interest rate, but now I'd like to know the value of these payments at time 20 years. Okay, so now I'm trying to push them all to time 20. Right, so I'm after CV20. My $100 has to get pushed forward 20 years, so multiply it by 1 plus I to the 20th. My $200 has to get pushed forward 19 years, so multiply it by 1 plus I to the 19th. And my $3,000 has to get pushed forward 15 years, so multiply it by 1 plus I to the 15th. and add those three new pots of money together. All right, so I replace I with 0.03, crank it out to 5205.21. All right, so these are very computational, but hopefully they will become straightforward problems. And the idea behind this is, for each of these three parts, I can either accept Aunt Hildy's set of payments, or equivalently, I could just say, you know what, I'll just take 2882 right now, and let's forget about the other payments. That would be the same thing, okay? Or I could say, you know what, Aunt Hildy, just give me $3,149.24 at time 3 instead of the 3 payments you're proposing. That would have the same value. Or, playing the long game, you could say, hey, you know what, Aunt Hildy, I don't need any money for like 20 years. So instead of these 3 payments, just give me the equivalent, which would be $5,205.21 20 years from now.